All right, here we go. Sliding filament theory. We are finally going to get into the details of this in this probably three-part video. We're going to start with the incoming nerve impulse. So what we have here is the neuromuscular junction. And let's go back over things that we have already talked about. So here is my axon terminal or my synaptic knob. This gap is going to be the cleft. This label here is showing that this arrow is pointing to this gap. So let's note some of these terms. This is the synaptic cleft. I have vesicles in the knob that have my neurotransmitter, and the neurotransmitter here is called acetylcholine. Acetylcholine is the neurotransmitter that causes muscle contraction. So let's just find that out. Acetylcholine is the neurotransmitter that causes muscle contraction. And as we get into this physiology, we're going to see again and again and again that it's going to come down to calcium and sodium. So let's just refresh your memory. I'm here in the corner. I'm just going to write down what we need to know that the Ca plus 2 is calcium. And Na plus 1 is sodium. Because it doesn't exist, it always exists in the ionic state. So if you see Na plus 1, that's sodium, and Ca plus 2, that's calcium. All right, so what else do we have? Here we go. Back when we did the anatomy of the muscle fiber, sorry, I couldn't say my word, we had the T-tubules. So what I have here are the T-tubules. These are those openings into the sarcoplasmic reticulum. Here I have this structure here is my sarcoplasmic reticulum. Sarcoplasmic reticulum. Here I have my terminal cisterns. And then down here, this thicker red, this is my myosin. And this is the blue is my actin. And what they've done is they've cut sarcoplasmic reticulum here so that you can see, now if my sarcoplasmic reticulum was in place, it would stretch over the whole top of this. And I would have another terminal cistern down here. And that sarcoplasmic reticulum lays on top of the actin and myosin like a net. Another thing that we need to put in that I don't have, and I'm going to do these guys in purple, are receptors. So I have receptors over here. Let's make them round, show that they receive the acetylcholine. Let's give ourselves about 3 receptors. So these structures are acetylcholine receptors. Okay, so now that we have the lay of the land, I'm going to write down the steps. And we're going to start with step 1, and we'll end up with step, I think it's like 13 or 14. So this is a pretty long process. Step 1 is a nerve impulse reaches the end of the neuron or the axon terminal. So a nerve impulse arrives at the end, arrives at the synaptic knob. In order for a muscle to fire, we have to have a nerve impulse. So, and this is voluntary, a voluntary nerve impulse. It's generated by our own thought. You know, the thought is, I want to pick up my pencil. So we're going to have to contract muscles to do that. So that message gets sent from the brain down that motor neuron, and now we're at the end. Here I have my vesicles with acetylcholine. So what'll will do is once that nerve impulse gets to the end of the axon, the acetylcholine will be released across into the synaptic cleft. So step 2 is the acetylcholine is released into the synaptic cleft. And we said in the last video, the way that happens is these will move down to the end, they'll bind. And when they bind with the end, then they'll release their neurotransmitter into that gap. You could call it the synaptic cleft or the synaptic gap, either way. And these guys are going to bind then with the receptors. So step 3 is the acetylcholine. I think I better move this party because I can make it work. The acetylcholine binds to the receptors. These receptors are kind of like a locked door. As long as the acetylcholine isn't bound to them, they're closed. But what happens when this acetylcholine binds is they open up a gate. They have, so we should probably add 2 gated receptors. They have these gates, and the gates open up, and the only thing that can go through the gate is sodium. And so when those gates open, let's make this color, make sodium light blue. So everywhere we see light blue, that's going to be sodium. So when these open, sodium is going to flood in, and it's going to flow into this membrane, which is the membrane, the cell membrane of the muscle fiber. By the way, one of the things that I forgot to put into the notes back when we did the anatomy of a nerve cell, let's show this as sodium dots, is that the membrane of the cell membrane of a nerve cell is called the sarcolemma. So if you pick up a video and you want to watch a video on this, they're going to talk about the sarcolemma. This is the sarcolemma. So that's what this term is up here. We'll put that in brown. So this, and these T-tubules, what they do is they let the sarcolemma come all the way down. Usually the cell membrane wraps around the outside of the cell. But in the case of a muscle fiber, the cell membrane can go all the way through the middle of the cell because we have these T-tubules. All right, so let's go back. We've got the impulse coming in. The acetylcholine comes to the end and is released into the cleft. It binds with receptors. The receptors open, allowing sodium to flow into the sarcolemma. The receptors open, allowing sodium to flow into the sarcolemma. And think about if you have a bucket of water and you open a valve and it flows wherever it can go. Well, these sodium ions will continue to flow, and they flow all the way down the cell membrane, including into these T-tubules. So it's going to go all the way through the cell, and it goes both ways. So this arrow is my sodium flow is represented with this arrow. So we have to understand when these gates open and the sodium flows in, it doesn't just stay in that spot. It flows all the way through, all the way down, and including into including the T-tubules. So let's add including the T-tubules. Because these T-tubules are part of the cell membrane. This is just basically an infolding of the cell membrane coming down into the cell. Well, notice what I'm right next to. I am right next to the terminal cisternae. And these guys, let's make calcium orange. The terminal cisternae are full of calcium. They are just chock full. So both of these sides, they've got tons and tons of calcium. Once the sodium is directly next to the terminal cisterns, it causes these terminal cisterns to release their calcium. So the next thing that happens, and we're going to come over to this side, step 5. The sodium in the T-tubules causes the terminal cisterns, cisternae is actually the correct plural term, to release their calcium into the sarcoplasmic reticulum. So the calcium is now going to flow out into the sarcoplasmic reticulum. So this is step 5. And remember, we've cut this sarcoplasmic reticulum away, but it flows over top of these actin and myosin fibers. So the last thing that we're going to say is calcium leaves the sarcoplasmic reticulum and begins the contraction process in the actin and myosin. So if I could put, if I take my numbers here, number 1, here's that nerve impulse coming in. Number 2, here is my acetylcholine going to the end of the synaptic knob and releasing its contents into the cleft. Number 3, the acetylcholine binds with the receptors. Once the acetylcholine binds to the receptors, sodium, they open and sodium flows in. So number 4 is this flow of sodium. When the sodium gets down to these terminal cisterns, 5, the calcium gets released. And then finally, now I'm out at the actin and myosin, that calcium is going to start the next leg of the journey. So what are our takeaways here? It's a very specific process. I was going to actually embed a video at the end of this to show you, but most of the videos, there's actually about 4 or 5 steps that we skipped. And so a lot of the videos are, I think it would confuse you more. You're welcome to go look at one, but understand there's things that I'm leaving off the table for the sake of simplicity. But our takeaways are, first of all, hopefully you were able to hang in there with all of the vocabulary, things like terminal cistern, T-tubules, neurotransmitters, synaptic vesicles, synaptic clefts. If you didn't have all of that down, you're probably pretty confused, and you might need to go back and pick up some of that vocabulary. Once that's down, this should make sense to you. But again, to take away our first 6 steps, the impulse comes in, it causes the acetylcholine to go down to the end of the knob and be released into the gap. Step 3, the acetylcholine binds to the receptors. Step 4, the receptors open and it causes sodium to flow down the sarcolemma or the cell membrane. even in down into the T tubules, which are an infolding of the cell membrane. When the sodium in the T tubules is next to the terminal cisterns with the calcium, it causes the terminal cisterns to release their calcium into the sarcoplasmic reticulum. And once there's calcium in that sarcoplasmic reticulum, step 6, it it enters into the actin myosin fibers, and it causes contraction to begin. All right, so that was part 1. That's 1 through 6. And we will continue in the actin myosin fibers in part 2.